All right, let's kick off our deep dive today. And we're going to be looking at open educational resources and how they're impacting physics education. And you know what? You sent over some really interesting stuff from back in 2014, a web page actually detailing a couple of public lectures at the National Institute of Education in Singapore. And these lectures were all about using computer simulations to teach physics. Now, what really caught my eye was that these lectures were actually part of an EduLab initiative funded by the Singapore National Research Foundation. So right off the bat, this wasn't just some, run-of-the-mill lecture series.
Oh, yeah, for sure. Having that backing from the National Research Foundation, I mean, that really suggests
Yeah.
that they were, exploring some pretty cutting-edge ideas in educational technology, even back then in 2014.
So let's get into it. This webpage focuses on two speakers in particular, Francisco Escambre and Felix J. Garcia Clemente from the University of Murcia, Spain, and Wolfgang Christian from Davidson College in the USA. What can you tell us about them and what they talked about?
Well, both of these speakers were really deep into using technology to kind of, boost physics education. Escambre and Garcia Clemente, they presented on something called Easy JavaScript Simulations, or EJS. It's a tool that allows educators to create these interactive physics simulations. And their lecture focused on how EJS could be used to create simulations specifically for tablets, which were, just starting to become more common in classrooms back then.
Tablets in 2014, that's pretty ahead of the curve. What about Wolfgang Christian's lecture?
So Christian's lecture took a bit more of a broader look at online computational physics resources as a whole. So he talked about Phizlets, which are these small interactive Java applets designed to teach specific physics concepts. And he also talked about the Open Source Physics Project, or OSP, which is this collection of open source software tools and resources specifically for physics education. And he highlighted how these resources were being integrated into the curriculum at Davidson College.
Wow, so it sounds like both lectures were really pushing the boundaries of how we could use technology to teach physics. I mean, developing these simulations back then must have been pretty challenging, right?
Oh, absolutely. I mean, the technology in 2014 was nowhere near as advanced as it is today.
Yeah.
Developing these interactive simulations, especially ones that could run smoothly on tablets, would have taken, a lot of technical expertise and a lot of creativity.
Yeah, I can imagine. The webpage mentions that they even developed a reader app for Android and iOS tablets to help organize and collect all these different simulations. Did anything about that stand out to you?
Well, what's really interesting is that they were already thinking about accessibility and ease of use.
Hmm.
Developing a dedicated app just to organize and access these simulations suggests that they understood, they knew that they needed to make these resources user-friendly for both teachers and students. It's like they were kind of predicting the whole, educational app boom that we have today. Yeah.
It's like they were laying the groundwork for the whole mobile learning revolution that was about to happen. But was there anything about the technology itself that you found particularly interesting or noteworthy?
Well, one thing that really struck me was their focus on making these simulations run on any device that had HTML5 plus JavaScript. That commitment to cross-platform compatibility, even back then, is pretty impressive.
Yeah.
Shows a real dedication to making these resources accessible to as many learners as possible.
That makes a lot of sense, especially when you think about the whole concept of open educational resources. It's all about breaking down those barriers to education, right?
Exactly. Open educational resources, or OER, are materials that can be freely used, adapted, and shared by anyone. The whole idea is to make high-quality educational resources available to everyone, no matter where they are, their socioeconomic status or their technological capabilities. And these lectures seem to really embody that spirit.
So these weren't just lectures about cool simulations. They were about something much bigger, right? Democratizing access to education. That's pretty inspiring.
Absolutely. It really shows a commitment to educational equity and the idea that everyone deserves the opportunity to learn and grow. And, to see that being put into practice in science education, no less, it's really quite remarkable. And, this whole commitment to open access, it's really highlighted by their mention of the Compadre Digital Library.
The Compadre Digital Library. Remind me, what is that again?
Right. So it's this U.S. NSF-sponsored repository of physics teaching resources. You can think of it like a giant online library, specifically for physics educators. It's got everything from simulations and animations to lecture notes and problem sets. And the best part is it's all freely available.
So it's kind of like an early version of those massive open online course platforms that we have now, like
Yeah.
Coursera and edX.
Exactly. It's a great example of how educators were already starting to see the potential of the internet, for sharing resources and creating a more connected learning environment.
It's pretty amazing to think that these initiatives were already underway back in 2014. But I'm curious, beyond just the technology, did they talk about the actual pedagogical benefits
Yeah.
of using these simulations and online resources?
Oh yeah, for sure. Wolfgang Christian, in his lecture, he emphasized how incorporating Physlets and OSP into the Davidson College curriculum really helps students develop some key skills, like computational thinking and model building.
Now, those are skills that go way beyond just physics. It's about problem solving and, applying these concepts to the real world.
Exactly. And by actually working with these interactive simulations, students could move past just memorizing facts and figures and really develop a deeper understanding of the physics principles at play. It's a shift from passive learning to active exploration, which is something we hear a lot about in education today.
And it makes sense. When students are interacting with these simulations, they can experiment, test their hypotheses, and see how things actually play out in a safe environment. It's kind of like a virtual laboratory where they can learn by doing it.
That's a great way to put it. And this whole approach, even back then, really aligned with the idea that learning should be engaging and empowering. Instead of just, absorbing information, students are encouraged to actively participate in the learning process.
Yeah, that's a really powerful concept. But I'm also wondering, did they talk about how these ideas were actually being put into practice in classrooms? It's one thing to talk about the theory, but it's another to actually make it work in a real teaching environment.
You're right. And luckily,
Yeah.
the webpage does mention that they held workshops, specifically for teachers in Singapore, focused on actually using EJS in their classroom.
That's great. So they weren't just developing these tools and resources in a vacuum. They were actually working with educators
Mm,
to make sure these innovations were being integrated into real teaching practices.
exactly. It shows a commitment, not just to developing the technology, but also to supporting teachers and giving them the power to use those tools effectively.
I bet those workshops were incredibly valuable for the teachers who participated. It's like they were getting a sneak peek into the future of education.
Yeah, and those teachers then went on to share those new approaches with their students. And who knows, maybe they even sparked a lifelong passion for science and technology in some of them.
It really makes you wonder, how many of those students went on to pursue careers in physics or even educational technology and are kind of carrying on the legacy of those early pioneers?
It's a nice thought. The idea that those initiatives might have planted the seeds for a whole new generation of innovators and educators.
It really speaks to the power of sharing knowledge and working together. These educators weren't working in isolation. They were part of a movement to push the boundaries of what's possible in education. And it's clear that their work has had a lasting impact.
Definitely their dedication to open access and these innovative teaching methods and their focus on teacher support. It paved the way for a lot of the advancements we see in education today. It's a legacy that's still inspiring us and shaping how we think about learning.
It's amazing how much these lectures from 2014 really foreshadowed the trends we see in education today. I mean, the focus on mobile learning and interactive simulations and open access, that's become like central to how we think about teaching and learning these days, especially in STEM fields.
Yeah, it really shows you how forward-thinking those folks were. They
Yeah.
really understood the power of technology in education way before it became mainstream.
Yeah, and it wasn't just about the technology itself either, right? It was about this whole philosophy of open access, this belief that everyone should have access to knowledge. And that idea is still a major driving force in education today.
For sure, that commitment to open educational resources
Yeah.
and to make sure that everyone has a chance to learn, no matter who they are or where they come from.
So we talked about the past, we've talked about the present. But what about the future? I mean, technology is changing so fast. What do you think the future holds for physics education?
Well, if you look at what's happened since 2014, I think we're going to see even more immersive and personalized learning experiences. Imagine virtual reality simulations that let students actually step inside an atom or experience the laws of physics firsthand, or AI tutors that can adapt to each student's individual learning style and pace.
Wow, that's pretty mind-blowing. It sounds like we're on the verge of a whole new era in physics education.
And I think open educational resources are going to play a huge role in making that happen. By providing high-quality learning materials for free, we can give everyone the opportunity to explore and experiment and discover the wonders of physics like never before.
It's a pretty exciting time to be involved in education. Well, this has been a fascinating deep dive. Thanks for joining me.
It's been my pleasure. It's always fun to look back at how ideas have evolved and how they continue to shape our world.
And to our listener, thanks for sending us this thought-provoking material. We hope you've enjoyed this deep dive into the world of open educational resources and that it's given you some new insights into the future of physics education. Until next time, keep exploring and keep learning.